Okay, we're going to practice naming organic compounds, looking at the molecule, and then getting the name and drawing out the molecule. In this case, you know you have organic compounds when you got carbons and lots of hydrogens. So let's just do this. First thing you're going to do is you're going to count the longest carbon chain for number one. That's easy. You have 3 carbons in a row. And since you have 3 carbons, you have the prefix prop, and they're all single bond, so that's propane, and that's how you name it. So propane. For number two, now all of a sudden you have a carbon-carbon double bond. You count the number of carbons, there's a total of 4, but when you name this, you're going to name this 1-but for 4 and ene for an alkene because of the double bond. Now, when you count the longest chain, you have to count it from left to right and right to left. In other words, 1, 2, 3, 4, or 1, 2, 3, 4. Wherever the double bond starts, that's where the number comes in. So the number 1 is less than the number 3, counting it from right to left. So this is 1-butene. Now, we have 5 and 6 right here. Let's do it. You count the longest chain. For number 5, you got to be careful. A bend, B-E-N-D, in the molecule does not count as a branch. So we have 4 in a row. We have all single bonds. So this is known as a butane. Now, I could take, once I start with 4 carbons, I could have this group known as a methyl group stuck in the middle. I have to be careful. So this is just what we call N-butane for normal, meaning it's a 4-carbon chain. Let's take a look at number 6. Now 5 and 6, you'll notice total number of carbons are 4. This also, number 6, is a butane, except we don't name it that way. These are known as isomers, isomers. They have the same number of carbons, same number of hydrogens, but different arrangement. In the case of number 6 here, my longest chain, no matter how I count it, I got 3, or I got 3. So the base name is prop. They're all single bond, ANE, but this group right here is known as a methyl group. We use the prefix now, and we're going to call it methyl. That's a Y and an L there, by the way, methyl propane. So methyl propane and N-butane are isomers. Let's check out some more. Before we go any further, let me explain this whole idea of branches. These are carbons and hydrogens that literally branch off the main molecule, the backbone, if you will. Let's take a look at the 2 branches, especially if you're taking Regents Chem or high school chem, that you're usually most often going to see. Methane, you probably already remember that methane is just good old CH4. Okay, a methyl group is when we pulled off one of the H's and we have 3 H's, but we got 1 more bond left. And that is going to attach itself to the molecule. If I go ahead and I blow this out, right, we have the tetrahedral shape, which you can't see on a 2-dimensional surface. But one of the 4, this is where it would get attached to the molecule. That is known as a methyl group. Now, if I have ethane, ethane is CH3, CH3, C2H6, but I'm just kind of showing you a condensed structural formula. In other words, for ethyl, now the group, I got 1 H off. I could go ahead and list it as C2H5, for example, and now it's going to bond to the rest of the molecule. Branches don't have to just be 1 carbon or 2 carbons. You can have, of course, propyl groups and butyl groups, etc. But these are the 2 that come up most often that you're likely going to see. So let's go back and check out some more. All right, let's check out these 4. You might want to pause the video, try it for yourself, and then come on back. Let's do this. For number 3, look at the number of carbons that we have. We have a 3-carbon chain. 3 carbon chains, of course, the prefix is prop. I only have a triple bond, 1 triple bond, and then the single bond. So this is propyne. All right, I don't have to indicate where the triple bond starts, because if I flip the molecule, literally just take it and flip it around, that's no different than a bend, right? As far as naming. In fact, let me show you some other thing quick. Now, don't forget, if you're taking Regents chemistry, we have some organic tables here that you are going to use. And we have reference table P that gives us the prefixes. So the number of carbon atoms tell us the front of the name of the molecule. And down here in Q, we have 3, this is just 3, of what's known as hydrocarbon series: alkanes, alkenes, and alkynes. So alkanes, all single bonds between carbons. Alkenes, ENE ending, you have 1 double bond. And alkynes, you have 1 triple bond. This general formula here that you see, that would mean you could plug in any number of carbons, and then that's your N number, and then you would go ahead and you could calculate the number of hydrogens that would go along with that number of carbons for that molecule. Let's go back. Alrighty, for number 4 now, once again, we're going to count the longest chain. There are 5 carbons here all the way across. Now, if I go ahead and I go 4 and then 1, it's still 5. Or if I go 5 from right to left, or 3. So 5 is our longest chain. The prefix then is pent, P-E-N-T, and we have all single bonds, so it's going to be a pentane. But now I have this CH3 group, that's our methyl group. So this is going to be methyl pentane. Now, pent is 5 carbons. This methyl group could have easily been on the middle carbon, so I have to add a number to it. When I number, I take the longest chain and I number it from left to right. So 1, 2, 3, 4, and 5. And from right to left, 1, 2, 3, 4, and 5. Since 2 is a lower number than 4, this is known as 2-methyl pentane. On to number 8. Okay, so for number 8, we have this pretty big molecule, but no matter how I count, right, I have 5 carbons going across this way, I have 5 going that way, I have 5 going this way, you get the point. So 5 is still the longest chain. So it is a pentane again, as far as the base name, although for number 4, our methylpentane and number 8 are not isomers, because now what do I have? I have on the 3rd carbon, it would be number 3 no matter which way I count it, I have 2 ethyl groups. Now, we don't call it ethyl pentane. Instead, we're going to use the prefix di, di. So this is di ethyl pentane. I don't need the number 3 here because this is the only place it could be. If I move it over to the left or to the right, it would be longer than 5 and it wouldn't even be named pentane anymore. So this is diethyl pentane. Let's keep going. Alrighty, in these cases now, we're doing the opposite. We're given the name, we got to draw the structure. We go ahead and we process the word. So for ethane, we have the prefix eth, that means 2 carbons. A and E means they're all single bonds. So I'm going to draw 2 carbons. That's the first thing you do, is draw out your carbons. Remember, carbon has 4 valence electrons. It needs 4 more to get to the magic number of 8. And so we're going to go ahead and make sure carbon has 4 bonds. On this left carbon right now, it's used up 1 bond. with the other carbon, it has 3 left. So I got a hydrogen, and a hydrogen. And then for the second carbon, hydrogen, hydrogen, and hydrogen. There we go with ethane. Let's go over to number 5 for ethyne. Ethyne, 2 carbons. I go ahead and I draw my 2 carbons. But the YNE ending now means I have a triple bond. Well, if each carbon has already used up 3 of the 4 bonds, it only has 1 more left. And there it is, H and H. So when you're putting these molecules together or laying them out, it's almost like, pieces of a puzzle. Carbon gets 4 bonds, hydrogen gets 1 bond. We're going to be looking at halogens next. They only get 1 bond too. And you just piece the puzzle together. And remember, if you are taking Regents Chem, you also have the reference tables to help you. Use them. For number 2, we have propene. Prop means 3. So I'm going to draw out 3 carbons. ENE tells me I have 1 carbon-carbon double bond. Now, since it's a short molecule, it doesn't matter if I put the double bond on the left or the double bond on the right. And now I'm just going to fill in my hydrogens. Every carbon gets 4 bonds. I got 2 here left for hydrogens. Notice the carbon in the middle has already used up 3. It has 1 left. And then the carbon on the right has used up only 1. So I'm going to go ahead and draw in 3. And this is propene. Now, it doesn't matter, by the way, whether I put, for example, the middle carbon, whether I put the hydrogen on the top or the bottom. They can spin around. Don't worry about that. Just make sure you have them drawn in. All right, for number 6 here, 3,3-dimethyl pentane. Again, you're starting from the right with the word and moving to the left. Pent means 5. So I'm going to draw in 1, 2, 3, 4, and 5. I got 3,3-dimethyl. That means on the third carbon, I'm going to have a methyl group, a CH3 group. I'm just going to go ahead and condense it to CH3, and 1 here on the bottom for CH3. And then all I have left to do is to draw in the rest of the hydrogens for the other carbons. So the carbon here, way to the left, used up 1 bond. It's got 3 hydrogens left I have to draw in. Now, a lot of times, students will get tired of drawing in all the hydrogens. You got to at least show the lines, right? The carbon to the right of that has already used up 2. It's got 2 hydrogens to get to 4. Of course, the carbon on the third carbon, you've already used up all 4 bonds. And then to the right of that, another H here and an H here. Sorry, this is kind of sloppy. And then finally, the N carbon on the other side has only used up 1 bond. You got 3 hydrogens you got to put in. And this is it, 3,3-dimethyl pentane. Okay, let's keep going. Okay, in this case, if you have not tried it yet, stop the video, draw these out for yourself, see how you do. Let's do this. We're starting with number 3. We have bute. It's not butene, it's butene. We got 4 carbons. So I'm going to draw 4. And an ENE ending tells me I have a double bond. And that double bond needs to start with the second carbon. So I'm going to name them or label them 1, 2, 3, 4. I could have done it the other way. So in other words, the double bond is here between the second and third carbon. And now I have to go ahead and I have to draw in the rest of the hydrogens. Carbon 1 has used up 1. It has 3 hydrogens on it. Carbon 2 has used up 3 bonds. It's got 1 left. Carbon 3 has used up 3 bonds. It's got 1 left. And again, these hydrogens can go above or below. Doesn't matter. 1 above, 1 below, whatever you feel like. And then finally for carbon 4, I'm putting in my 3 hydrogens. Okay, that's 2-butene. If we go down to number 4, methane, meth, of course, means one carbon, A-N-E, well, single bond, it's only one carbon. Here it is, good old CH4. There is no such thing as methane with an ENE ending or methine. In order to have a carbon-carbon double bond or a carbon-carbon triple bond, you need at least 2 carbons. For number 7, 2,3-dimethylpentane. All right, you're going to draw out your 5. I'm going to just erase 3 and 4 so they're not in my way here. All right, so pent is 5, so 1, 2, 3, 4, and 5. Oh boy, my C's are looking pretty bad there. And then 2,3-dimethyl. So that means I'm going to put a methyl group on the second carbon and a methyl group on the third carbon. And then we fill it in with our hydrogens. And again, if you want, you could just use the lines to represent hydrogens. This carbon number 1 used up 1 bond. It had 3 left. That's why you got the 3 lines. Those represent hydrogens. Carbon 2, you have that methyl group. You only need 1 hydrogen. Carbon 3, same thing. You only need 1 hydrogen. Carbon 4, 1 and 1. And then finally 1, 2, and 3. Okay. And then finally for N-butene. N means normal. Normal means just straight across. But is 4. YNE means you're going to have a triple bond starting with the first carbon. So I'm going to draw my carbons. You always draw the backbone first. That's your structure, right? And then I'm going to throw in the rest of my bonds. The first carbon's already used up 3. Only got 1 left. The second carbon's used up all 4 bonds. No more hydrogens. And then I have 2 here because it's used up 2. And then 3 here. All right, and that is N-butene. Great. I would suggest going over the answers here if you're struggling before we move on to the next page. Okay, so you're going to draw out the formulas here for these compounds. These should be fairly straightforward. Use your reference tables, right? The prefix tells you how many carbons. You draw that out first, and then what you're doing as far as double, single, or triple bonds, and then filling up with hydrogens next. Remember, every carbon gets 4. So pause the video, do it, and then come back and check the answers. Okay, after trying to draw these on the screen, I finally decided, hey, print it out, draw out the molecules, and then scan it in so you can see it. In the first row, I added all the hydrogens except for 2-pentene, but where the lines are, those would be where hydrogens would be drawn. And then the second and third rows, I left out the hydrogens, just so you could see what the structure looks like with the carbons. Check it out, correct any mistakes that you have, and then we're going to slide on down to the rest of the page. Okay, for the rest of the page here, you'll see that all of a sudden now we're adding some methyl groups, and then we're even adding a chlorine here, all right, with 3-chloropropane. And this is, of course, a halogen. All halogens have 7 valence electrons. They only need to share and feel like it has the number 8, so it forms a single bond, is what I'm trying to say. So for 3-chloro-1-propyne, the 1 tells you where the triple bond starts, and then the 3 tells you where to put the chlorine atom. And then you'll see for some of them, for example, 2-methyl propane, I just use the condensed CH3 for the methyl group, but then in 3-methyl pentane, I show you that, right, it's CH3, you have to put the 3 hydrogens there. Now, some teachers will allow you not to draw in all the hydrogens, just to make sure you show the lines that understood that it's bonding to hydrogen. Even on the New York State Regents in the past, an answer key will have it drawn with hydrogens and without, as long as you have the lines. Okay, on this last page of the 4, you see more going on with halogens again. We got some chloros, we got a bromo, we have chloro and bromo, methyls, etc. Let me show you something on the New York State Regents reference table quick here. Okay, the halogens that show up on an organic molecule are part of what's called organic functional groups. And you see here we have fluorine now becomes fluoro, chlorine, chloro, etc. And anytime that you have a halogen on the molecule, you're going to have a prefix for that halogen in front of the base name of the hydrocarbon. It's not a hydrocarbon anymore because, of course, you have a halogen on there as well. The rest of these functional groups deal with oxygen and then oxygen and nitrogen that we can get into in a different lesson, but we're just taking a look now at halogens on organic molecules. You're going to go ahead and draw these out exactly as you would before. We start from the right and we're moving on left. Propane, 3 carbons, all single bonds. All right, 2-methyl means I have a methyl group on the second carbon. I'm just going to put it as CH3. And then 1,2-dichloro means I have a chlorine here on the end carbon and a chlorine here. Oop, I don't know what happened here. On the second carbon. The chlorines, any halogens are replacing hydrogens. So all I have to do now is just check that the carbons all have 4 bonds. This first carbon has used up 2, so I need a hydrogen here and a hydrogen here. The middle carbon has used up all 4 bonds, and then this other carbon on the end needs 3 hydrogens. And that's how you name it. So the numbers are your parking spaces, right? You set up your carbon chain. We'll do that again here with pentane, right? 5. So 1, 2, but this thing's not doing so good here. 3, 4, 4, and 5. And then 1 chloro. So if I'm going to name the one on the left as number 1, I'm going to put a chlorine. Now it does not matter. It could be up here, it could be on the end, it could be below, but I'll put it up here as chlorine. 3 ethyl. Ooh, so now what do I need? I need an ethyl group. That's 2 carbons and 5 hydrogens. So that's a longer branch, obviously, than methyl. I could draw the whole thing out, but I'm not going to, and now I have to fill in the rest of the molecule with my hydrogens. So the carbon here, the first carbon is used up 1 with chlorine, so it has a hydrogen here and 1 down here, which now is running into my arrow. Then the second carbon has used up 2 bonds. It's got 2 hydrogens then left that have to get bonded. Of course, this third carbon, you have the ethyl group, but then there's a hydrogen up here. Then this fourth one needs 2 hydrogens, 1 up and 1 down. And the third one has only used up 1 bond, so we need our 3 hydrogens. And again, you could represent these just as the sticks, but you have to at least show that you know the bonds. Oh, sorry about this, guys. All right. So that's it. Kind of sloppy, but that's 1 chloro, 3 ethyl, pentane. All right, we're going to go on to the next 2, and I'm going to erase this mess. Okay, again, go from the right and you're moving left. We have a butene. Bute means 4, so let's put in 4 carbons. Okay, 2,3-dichloro. So if I make, again, the one on the left, number 1, I have the second carbon, I'll put a chlorine, and the third carbon, chlorine. And then a bromo would go on the first carbon, that's a bromine. Oh, and I almost forgot, I need it's butene, it's a double bond. So 2-butene means it's between the second and third is the double bond. All right, what do I have left to do? I have to fill in the rest of the carbons, make sure they all have 4 bonds. So the carbon that's bonded to bromine has used up 2 bonds, so I need 2 hydrogens. I'm just going to draw lines. The second carbon has used up all 4 bonds. The third carbon's used up all 4 bonds. And the fourth carbon, I need 1, 2, and 3 hydrogens. All right, and I got to plug in my computer here. All right, let's move on to the next one. We got a 3-hexene, and then we have some chlorine and bromine on that. Hex is 6. ENE, I got a double bond starting with the third carbon. So we have 1, 2, 2, 3, 4, 5. I'm on 5 and 6. Okay, 3-hexene. So on the third carbon, that's where we have the carbon-carbon double bond. 3-bromo. On the third carbon, I have a bromine. And then on the first carbon, I have a chlorine. All right, and then the rest are going to be hydrogens, just like before. And let me do something fancy here. All right, so you see it. So hydrogen's there, right? That first carbon's used up 2, there's 2 left. The second carbon, got 2 left. The third carbon used up all 4 bonds. The fourth carbon, I got 1 left. Then I got 2, and then I have 3. All right, I would fill those in with hydrogens, and let's go to the next 2. All right, 2,2-dimethyl propane for dimethyl propane. Of course, prop means 3, so I'm going to draw my 3 carbons. This thing is a little delayed, sorry about that. 2,2-dimethyl means I have a methyl group above and below on the second carbon. And again, I'm just going to draw it as CH3 and CH3. I don't know what happened to my CH3 up here. Let's do this again. H3. What do I have left? I have left then to put the rest of the bonds on the carbons on the end. Each one's used up 1. So I have 1, 2, 3 hydrogens on the first carbon, and then 1, 2, 3 hydrogens left on the third. All right, let's play around with one more here. This 1,2-dichloro,3,4-dimethyl 1-hexene. All right, well, hex means 6. ENE means I have a double bond, and where does it start? It starts with the first carbon. Let me erase 2,2-dimethyl propane, and let's take a look. So I'm going to kind of go into the other box. So 1, 2, 3, 4, 5, and 6. All right, my double bond starts right there. Now I have 1,2-dichloro. Remember, the numbers tell me the parking spaces. I committed to number 1 being on the left. Why wouldn't I? I'm going to put 2 chlorines in. Now I'm putting them up and down. When you have a carbon, let's go back, for example, to ethene, carbon double bonded to just carbon. What you're going to see most of the time is your hydrogens almost out on angles. And here's the reason why. We talked about this when we did bonding, that atoms and lone pairs of electrons want to try to get away from one another as much as possible. So drawing it this way, they're going to be as far away as they can be than drawing it at a 90-degree angle. And that's why you see it. It's a little more chemically correct. It doesn't matter though as far as drawing these. If you happen to draw it this way, you're still fine. You'll still get credit. But just so you know that it's all about trying to get, atoms and electrons away from one another. Okay. All right, so the second carbon's used up 3. It's got one more, so it would have, oh, wait a minute, I lied. Before I fill in hydrogens, I still have my 2 methyl groups. So I have a methyl group here on the third carbon and a methyl group on the fourth. That's why my dimethyl. Di just means these prefixes just go with what you're substituting onto the molecule. All right, so if I go ahead and put in my methyls and I draw them as tiny little C's with my H's just to show you that's, the structural formula for methyl groups. It's not a bad idea. All right, now I would fill in the rest with hydrogens. The first carbon, of course, has used up all 4 bonds. Let's go back. So this is good. Second carbon's used up 3 of the 4. I would put a hydrogen there. The next carbon's used up 3 of the 4. I would put a hydrogen there. The next carbon, 3 of the 4, hydrogen. Here for the 5th, it needs 2 more hydrogens. And then finally for the 6th, 1, 2, and 3. Okay, so that was 1,2-dichloro, 3,4-dimethyl, 1-hexene. And now we're going to go down to practicing once again naming the structures. Alrighty. Well, you'll notice for all 4 of these examples, we're just dealing with hydrogens and carbons. So we don't have to worry about functional groups. We have no chloros or bromos here. What are we back to doing? Well, we have to go ahead and count the longest chain here in example 1. And if I go across, right, there's 6. Here, there's 3. And then 1, 2, 3, 4, 5, 6. So no matter how I slice it and dice it, the longest chain is 6. That prefix is hex, H-E-X, all single bonds. So it's a hexane. But you'll notice there is this methyl group. And when I go ahead and I put in the number for the methyl group, I'm going to want to count the longest chain from right to left and left to right. And whatever number is lower, that's our winner, chicken dinner. Okay, I'm trying to draw it right. Methyl didn't come out too good. In other words, this is 3-methyl hexane. If I named it as 5-methyl hexane, I could probably draw it, but using the rules, the International Union of Pure and Applied Chemist rules, we always want to have the lowest number. Okay, the second molecule here should be easy. In fact, this is on the reference table. You got 2 carbons, that's eth, and it's a double bond, so it's ethene, the E-N-E ending. Okay, let's go to the next one here on the right. We're going to count again. We have going across 1, 2, 3, 4, 5, or we have 1, 2, 3, 4, 5, 6. Oh, wait a minute. That's a longer chain. If I go from right to left, 1, 2, 3, 4. So 6 is the longest chain. So we're going to go ahead. Let me erase everything here. And we're going to go ahead and deal with this as 1, 2, 3, 4, 5, 6. So that's hex again. And we have a triple bond. So this is hexyne, which is the Y-N-E ending. And that is showing up starting with the second carbon. This is supposed to be an E. I don't know why my computer's so slow today. Sorry. So this is a 2-hexyne, excuse me. And then we have a methyl group here on the 4th carbon. So this is 4-methyl 2-hexyne. So anything other than hydrogens, we have to recognize. So 4-methyl 2-hexyne. And finally, for the last one here, fairly straightforward. I have 3 carbons. It's a prop. I have a triple bond. It's a propyne with the YNE ending. And it doesn't matter. I could flip the molecule around. This is 1 dash propyne, Propyne. I think you can see already just with dealing with carbons and hydrogens, or carbons, hydrogens, and halogens, there's a heck of a lot of compounds that can be made. Organic chemistry can be really, it's huge. The number of molecules, and then getting into reactions and interactions, it is, of course, really a branch of chemistry onto itself. I hope this helped. Keep working hard, and good luck.